Good morning. This question is from atomic physics. The focus of this question is trying to test your knowledge on the understanding of Bohr's model. The Bohr's model has postulates which he gave. The postulates were that the electrons are in stationary orbits around the nucleus, right? So that was postulate number one. And then, of course, the second postulate was that these electrons move into different stationary orbits once they are excited, right? So the first one is the electrons are revolving in stationary orbits, okay? The electrons are revolving means they are not stationary, the orbit is stationary. So the orbit is fixed in which the electron is moving. Okay, so let this be the nucleus, and this is positive. The centripetal force is coming from the nucleus, the positive nucleus. Okay, so and he did the study for a hydrogen atom, and you can see this question is also for hydrogen atom. And before I do the question, I will just quickly tell you about the postulates. The second postulate was that the electron will jump to another orbit only when it receives energy from some radiation or due to some collision, and then it moves to another orbit. So the movement between two stable orbits or so-called stationary orbits is dependent on some electromagnetic radiation being absorbed by the electron or vice versa. The electron is in higher energy state. So this is the higher energy state. The electron loses energy through electromagnetic radiation and comes to a more stable orbit. So the closer you are to the nucleus, more stable you are, right? So this is n is equal to 1, more stable. The postulate was more about how the electron moves between the stationary orbits when they're excited by an external source or they get de-excited. The third one is the focus of this question. Okay, if you see the question talks about if there are two different hydrogen atoms and each atom is in excited state, is it possible for the electrons to have different energies but same angular momentum according to Bohr's model? Okay, so the third postulate which he gave was that the angular momentum which electron carries is always a multiple of h by 2 pi. Okay, if you know the angular momentum is mvr, and this is the postulate which the students find very hard to understand because I think the class 11th knowledge of angular momentum is not there. Okay, so you must know that angular momentum is a vector, and anything which is in rotation, revolution. So, for example, this electron is in revolution, around a nucleus, has an angular momentum. If a body is moving linearly, it has a linear momentum, which is p, and the equivalent of a linear momentum is angular momentum. Okay, which is, so this number n is the heart of understanding this question. N is the the so-called the azimuthal principal number. So forget what it means. What it means is that n can have values 2, 3, 4. So any electron which is in, for example, this is orbit number 1 and this is orbit number 2 and then orbit number 3, 4. The angular momentum which the electron can have has to be multiple of this number. Has to be. It is mandatory. Otherwise, it cannot be in that particular orbit. Okay, and therefore the significance of understanding. Now you see the word orbital angular momentum in the question. So therefore, it is very important that you understand that electron has an angular momentum because it is revolving, but it is not an arbitrary angular momentum. It is a multiple of n. 1, 2, 3, 4, 5, whatever it is, right? So this has to be well understood that angular momentum has fixed values and not arbitrary values. These fixed values are multiples of n. This is point number 3. This is the postulate which you must understand. All right. Now let us go back to the question and try to understand what the question. So it says there are two different atoms. So let's say you have atom number 1 and you have atom number 2, and then you have orbits, and then you have orbits, then you have orbits, and then you have orbits, right? So these are the different orbits that. So these are two different hydrogen atoms, atom number 1 and atom number 2, and then you have, of course, the nucleus. Now it says that is it possible for the electrons to have different energies but the same orbital angular momentum? Now remember, orbital angular momentum is struck with n. There is no choice. If you are having an angular orbital momentum, for example, these two are separate hydrogen atoms, and I say there is an orbit number 3, and this has a different. It is struck with 3 as the principal quantum number, n. So it is quantized. It has to be multiple of 3 in the third one, right? So if you have same orbital angular momentum, but you're in two different atoms, it does not mean that your principal quantum number can change. If the angular momentum is same, it means n is also same. So if the angular momentum of electron here is L, for example, in the second one, the other one also has to be in the second one, because the angular momentum is only dependent on n and is a multiple of Planck's constant divided by 2 pi, right? So the only dependency is L. If you are already dependent on n, and that means you have same orbital, then n is identical for the same. Now let me come to the logic. Okay, I've repeated this many times so that you understand. Listen to it. I don't know which sentence will hit your mind and you will be able to understand. Now remember, the radius in Bohr's atom is also quantized. It is proportional to n square. The radius of the orbit cannot be an arbitrary number. It is fixed. Okay. Similarly, the energy is also quantized. You cannot have any energy. It has to be this. You might have seen these formulas of minus 13.6 divided by n square electron volts. The dependency of energy in an hydrogen atom of an electron is on, again, principal quantum number. Okay. Now we understand that there is something called as a quantum number, which is deciding what value of radius you will have. And this question is for hydrogen, by the way. It is not meant for anything else. So we will restrict the discussion to z is equal to 1, which is the atomic number. So the conclusion of what I've discussed so far is energy is quantized, is completely dependent on n. The radius is completely dependent on n. The orbital angular momentum is completely dependent on n. Now, if you have two different atoms having same orbital angular momentum, which is only possible if the n of the electron which they are referring to is identical. There is no other option. I'm just repeating it 100 times now. If n is identical, then the energy also will be identical. You cannot carry separate energies because energy is also dependent and a function of n. I mean, obviously the formula is proportional to 1 by n square, but it's dependent. If n is fixed for both these atoms for the electron, then the energies are also fixed. So my answer to this is, it is not possible for us to have electrons having same L to have different E's. Okay, when I say E, I mean the energies. So I hope this made sense to you. It's a very straightforward question. If you read it, put in a very different language. It is the basics of Bohr's postulate number 3, and some derivation of radius and E, which I did as a quick revision to make you understand what is a principal quantum number. And then I said since angular orbital momentum is common, so n is common. If n is common, E has to be common. I hope this made sense to you. The answer is no, it is not possible for these electrons having same orbital angular momentum to have different energies. Thank you very much for your time. Do watch my playlist on atomic physics. You will find some fantastic, basic level questions to advanced level questions, depending on what you're preparing for. If it's CBSE, State Board, AP Physics, SAT Physics, you're preparing for IB Board, across the globe, whatever you're preparing for, you will be facilitated by my channel. Immense amount of discussion and explanation available. What I need is a motivated student who can listen through the whole video. Thank you very much for your time today, and wait for my next video.